हेलो एंड वेलकम। कई बार ऐसा होता है कि किसी क्वेश्चन को देखकर हमें ये ध्यान तो आता है कि इसको कहीं देखा जरूर है, इसमें कुछ ट्रिक था, इसमें कुछ मैथमेटिकल मैनिपुलेशन था, बट एग्जैक्टली वो ट्रिक क्या था, वो मैथमेटिकल मैनिपुलेशन क्या था, ये ध्यान नहीं आ रहा है और इसलिए वो क्वेश्चन हमसे सॉल्व नहीं हो पा रहा है। ऐसे क्वेश्चन जब भी हमारे सामने आते हैं, हम बहुत एफर्ट करके उस ट्रिक को या उस पैटर्न को रिकॉग्नाइज करके याद करने की कोशिश करते हैं। कितनी प्रोबेबिलिटी होती है कि ऐसा ही एक ट्रिक, एग्जैक्टली ऐसा ही ये ट्रिक या शायद यही वाला क्वेश्चन आईआईटी के एग्जाम में भी आ जाए? मोस्ट प्रोबेबली इसकी प्रोबेबिलिटी बहुत ही छोटी होती है। इसके बावजूद हम एफर्ट मारते हैं उस पैटर्न को रिकॉग्नाइज कर। ये अच्छी बात है, पर एक और टिप देता हूं, ध्यान रखिएगा। ऐसा जब भी कोई आउट ऑफ द बॉक्स थिंकिंग वाला क्वेश्चन आए, कोई ट्रिकी मैनिपुलेशन वाला क्वेश्चन आए, तो उसमें उस मैनिपुलेशन, उस ट्रिक से हटकर ये भी जरूर सोचिए कि क्या इसको जो मेरा रेगुलर नॉलेज है उससे किया जा सकता है। हाँ ठीक है, कुछ स्टेप शायद एक्स्ट्रा लगें, पर क्या ये नॉर्मल यूजुअल रूटीन तरीके से क्वेश्चन सॉल्व किया जा सकता है? अगर किया जा सकता है तो उस ट्रिक को, उस मैनिपुलेशन को याद रखने का दबाव आपके ऊपर नहीं रहेगा। और फैक्ट ऑफ द मैटर इज कि जब भी वो क्वेश्चन या उससे मिलता जुलता क्वेश्चन आपके सामने आएगा, आप जरूर उसको सॉल्व कर पाओगे। ऐसा ही एक क्वेश्चन ईरोडोव से लिया है मैंने, और इस क्वेश्चन को देखते ही आप में से बहुत सारे लोग बोलने वाले हैं, हाँ हाँ ये तो हमने किया हुआ है, देखा हुआ है, हमें आता है। कर दो बेटा, मैक्सिमम लोग फंस जाने वाले। वो मैथमेटिकल स्टेप जो उन्होंने याद किया था वो शायद ध्यान नहीं आए। अगर कुछ समय बीत गए हैं तो डेफिनेटली ध्यान नहीं आने वाला है। मैं इस वीडियो में इस क्वेश्चन को रेगुलर तरीके से करने की कोशिश करूंगा। इसके सॉल्यूशन जो आमतौर पर इंटरनेट और यूट्यूब पे अवेलेबल हैं, वो इरोडोव की बुक में ही दिए गए हिंट से इंस्पायर्ड हैं, पर वो एक ट्रिकी ऑब्जर्वेशन है, और ऑब्जर्वेशन होने के बाद भी उसका एक ट्रिकी यूज़ है एक तरह से। तो अगर वो ऑब्जर्वेशन आपको हिट नहीं करता है तो क्या आपसे ये क्वेश्चन नहीं सॉल्व होना चाहिए? डेमोन्स्ट्रेट करने की कोशिश करूंगा कि नहीं, रेगुलर स्टेप से भी क्वेश्चन को सॉल्व किया जा सकता है। हाँ, हो सकता है मैथमेटिक्स के 2 स्टेप ज़्यादा लगे हमें। आइए देखते हैं हमारा आज का ये क्वेश्चन। आ गई ना बात याद कि हाँ हाँ ये हमें आता है? चलो, जिनको नहीं आता है वो तो कम से कम सुन ही लें, और जिनको आता है तो दोबारा जरा ट्राई कर लें। A small disk A is placed on an inclined plane forming an angle alpha with horizontal. This is an inclined surface. It makes an angle alpha with horizontal. And there is a small disk-like object kept on this inclined plane. It is imparted an initial velocity v0. Find how the velocity of the disk depends on angle phi shown in the diagram if the friction coefficient, which has been denoted by k, is equal to tan alpha, and at the initial moment phi naught is equal to pi by 2. First and foremost thing, try to understand the question. What exactly the question is asking? I am getting out of the frame for a second. Take the snapshot and try to construct the question on your own. The question says that initially this angle is pi by 2, which means if this is x direction, then initially the disk was projected in y direction. This is y direction. This is x direction. So initial angle between x direction and velocity vector is 90 degree. That is what the question says. This is some intermediate position that has been shown in the diagram. And coefficient of friction is tan alpha. Coefficient of friction is tan alpha, which means actually this is angle of repose, isn't it? If you just place the disk over here and leave it, it will not slide. It will be on verge of sliding, which straight away tells you that friction force is nothing but mg sin alpha. Can you see that? If there is an inclined plane, which we usually draw like this angle is alpha, there is a block placed over it. You leave it and it is on verge of sliding. The angle alpha is angle of repose. It simply means that this mg sin alpha is being balanced by the limiting friction, which is mu into n, mu mg cos alpha. So these two are equal actually, which means mu is equal to tan alpha. In place of mu, they have written k, but let us write it as mu only. So the friction force is at its limiting value. When you push the disk, the friction is kinetic friction now, but its value will remain mg sin alpha only. I mean mu mg cos alpha. In place of mu, if you write tan alpha, it will become mg sin alpha only. So the friction, kinetic friction, will remain mu into n, which means it will remain constant in magnitude mg sin alpha. Apart from the friction force, one constant force is acting on this body when it is moving in this xy plane, and that is mg sin alpha. Mg sin alpha is the force that always acts along x direction. It has fixed magnitude, fixed direction. The friction force has fixed magnitude in this question, but its direction is continuously changing. The friction force is always against the velocity, of course, opposite to the direction of motion. So friction force in this particular question is having a fixed magnitude. I hope you have understood that. Mg sin alpha is its magnitude, but its direction will obviously be always opposite to velocity. That means tangential to the path. Now the usual regular solution to this question revolves around the hypothesis that the magnitude of tangential acceleration and most probably the x component of acceleration, they happen to be same. And using that with a small tricky mathematical manipulation, you can establish a relationship between v and phi. So that is not what I am going to do here. What I will try to demonstrate is we can easily solve this question by regular way. Regular way means how do we deal with curvilinear motion? When a particle is moving on a curved path, how do you go about it? You usually resolve all the forces in two perpendicular directions, tangential and normal to tangent, that is normal direction, right? This tangential force is mass times tangential acceleration, mass times rate of change of speed. And this radial force or normal force is something that provides the necessary acceleration for changing the direction of velocity. And this acceleration is v square by r, where r is radius of curvature of the path, or if you don't want to involve radius of curvature, you can also write it as v into omega, where omega is the rate of change of direction of velocity. Velocity is a vector and it is continuously changing direction as the particle moves on this curved path. So when this vector is changing direction, that means it is rotating, and it is rotating at an angular speed omega, which means from any fixed direction, like in this question x-axis is fixed direction. This is the angle phi. If the velocity vector makes an angle phi with this fixed direction, and the rate of change of phi is nothing but omega. The velocity vector is changing direction at a rate of d phi by dt, which we are terming as omega. Then the radial acceleration is v into omega. If you don't happen to understand this concept, long back I made a video on rotating vectors. I will make sure to give the link in the description box. Please do watch that video, and it is a genuinely good video, and it will give you lot many concepts. It will help you in solving lot many physics problems. So go back to that video if you don't understand why I have written normal acceleration as v into omega. I'll not explain this one here right now. So let us move to solve the problem. What are we going to do? We are going to resolve all the forces in tangential and normal direction. And this is what we regularly do when dealing with curvilinear motion. So mg sin alpha is this force, and friction, which is also equal to mg sin alpha in magnitude, is in tangential direction. We have considered the disk at a position when velocity is making an angle phi with the x-axis. Now what is the force in tangential direction. mg sin alpha cos phi minus friction. So mg sin alpha cos phi minus friction, mg sin alpha, is mass times dv by dt. Divide on both sides by mass of the particle and you get dv by dt tangential acceleration as minus g sin alpha 1 minus cos phi. I have written minus g sin alpha so that this is actually, this bracket becomes positive, right? So it shows that dv by dt is negative, which means speed is decreasing, which is the case in this particular question. Speed is decreasing, isn't it? Why? Because cos phi cannot be greater than 1. So this is a positive number. So obviously dv by dt is negative. Okay. Now, we do not want to involve time in our equations because question is asking to relate v and phi. So we need to get rid of time. One way of doing this will be, we are going to write dv by dt as dv by d phi into d phi by dt using chain rule of differentiation. This is something that you learn very initially in kinematics. So now our attempt is going to be to get rid of this d phi by dt somehow. Is it possible to express this d phi by dt in terms of variables v and phi only, not anything apart from v and phi? So let us see that. One equation is still left out, and that is equation in normal direction. So in normal direction, as you can see again, this is mg sin alpha. So in normal direction, only the component of mg sin alpha remains, and that is mg sin alpha cos phi in this direction, mg sin alpha sin phi in this direction. So that is the only normal force acting. So the normal acceleration will be obviously g sin alpha sin phi. I have divided the force by mass. Now, as I said just now, that this normal acceleration can be written as v into omega. What is omega? Omega is nothing but the rate at which this velocity vector is rotating. If this velocity vector is making some angle phi with this fixed direction, the rate at which phi is changing d phi by dt is the angular speed of the velocity vector. But I have written it as minus d phi by dt. Can you tell me the reason? Because this phi is decreasing with time. So d phi by dt is inherently negative quantity. I just want its magnitude. So minus d phi by dt gives me the magnitude of d phi by dt. Magnitude of omega, so-called omega. The rate, omega is the angular speed at which velocity vector is changing actually. At which velocity vector is changing its direction, I should say. So minus d phi by dt into v, v into omega. Omega is d phi by dt. That is the normal acceleration. And it should be equal to g sin alpha sin phi. If you have not understood this, I remind you once again, I have given a link in the description box of this video for another video, which is a fantastic video which will help you in learning many other concepts. Do watch it. So now, actually we have solved the question, isn't it? I'll again bring back equation number 1 from the last slide. I have again written it here. Now you can easily get rid of d phi by dt. From equation number 2, you can find d phi by dt and substitute over here, or just take ratio of these two equations. So if you eliminate d phi by dt by dividing equation 1 with 2, you get this. dv by v is equal to 1 minus cos phi by sin phi into d phi. The problem is solved. This is the relationship between v and phi. Integrate on both sides and the question is solved. Now I leave that integration for all of you to do. Limits of integration will be, initially phi is pi by 2, and after some time it is phi, and velocity, magnitude of velocity, v is actually speed here. It is initially v naught, and at some later time it is v. So if you do the integration properly, you will get this relation. अब ये रिलेशन देख के भी कुछ लोग हंगामा मचा सकते हैं कि आंसर नहीं आया. नहीं, आंसर आया. जो किताब में आंसर लिखा है वही है. ये थोड़ा सा ट्रिगोनोमेट्री कीजिए, वही दिखेगा आपको. इसको दो एक्सट्रीम केस में चेक करके देख लेते हैं. When phi is pi by 2, initial case. When phi is pi by 2, this becomes pi by 4, sec square pi by 4. Sec pi by 4 is root 2 square, which means b is equal to v naught, which is the right thing. When phi tends to 0, after a long time, suppose it is a very long inclined plane, and as you can see in the diagram, the particle is getting nearer and nearer to x-axis. So after a long time, maybe the velocity will get parallel to x-axis. When phi becomes 0, this quantity will become 1, and the speed of the particle will become v naught by 2, which is less than v, and okay, it's kind of satisfactory, isn't it? After that, what will happen? Will it not decrease further? No. Why? Because mg sin alpha this way and friction this way, they are equal and opposite. Net force on the particle has become 0, and it will continue to move on a straight line parallel to x-axis with speed v naught by 2. I hope the video was not intended to give a solution to a question. Basically, I intended to tell you that whenever you see something out of the box in a question or some great mathematical manipulation, please stop for a while and give it a thought whether it can be done using some regular approach. Most of the time you will find that yes, it can be done. And that is something that teaches you much more than this out of the box step. This out of the box step is difficult to retain in your mind, and moreover, it may not work in many other situations. I hope you got my point. See you. Goodbye.